So section 2.5, all the problems have equal signs and fractions. And I'm going to solve all the problems using the same kind of strategy. Because the problems have equal signs, I expect to get number answers, maybe one answer, maybe two answers. And I'm going to need to check my answers. And this is a really big deal in this section. It turns out that the strategy for solving the equations that we use sometimes produces solutions that don't check, so we need to check everything. To solve the problems in this section, the first thing I'm going to do is I'm going to make each fraction have the same denominator, the least common denominator, which means I need to be able to figure out what the LCD is. I need to know what the LCD is, and then I need to know how to make the fraction have that LCD. In problem 2, the first denominator has a single x without any adding or subtracting being multiplied. The middle denominator has an x. That far right denominator, the 6, doesn't have an x. I'm going to give it an x. Now each of the three fractions have an x in the denominator, and if I give something to the denominator, I need to give it to the numerator. So when I brought the single x into the right denominator, I popped it up top. So now all the denominators have an x. I need to get the same number preceding the x, which is going to be a 6, because I can turn a 3 into a 6 by multiplying by 2, and I can make a 6 in front of that middle x just by multiplying by 6. So left fraction, I'm going to multiply by 2 over 2, and that's going to make 14 times 2 in the numerator, which is 28, over 2 times 3x in the denominator, which is 6x. After the minus sign, I'm going to multiply the fraction by 6 over 6. That's going to give me 30 over 6x in the denominator. And to the right of the equal sign, that negative 1x over 6x, that already has the common denominator. Once I get all the fractions that have the common denominator, I'm going to clear the fractions. Usually we show something like this. To clear the fractions, we take the whole entire equation and put it in a giant parentheses, put the common denominator to the left of the parentheses, and then I go cancel, 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 cancel. So that's clearing or canceling the fractions. This is going to leave me with 28 minus 30 equals negative 1x. And now I'm going to solve the equation. If there's a square, I need to set to 0 and factor. If there's not a square, I get the numbers on one side, the letters on another, and divide. And then it's going to be hugely important to do the checking. I'm going to use my calculator to check because it's quick and it's accurate. So I've got the fractions gone. I'm into the solving mode, and because there's not a square, I'm going to get the letters on one side, which I already have, and I'm going to solve by dividing. Well, I need to combine the 28 minus 30 real quickly before it makes sense to divide. So on the left-hand side, I'm going to write a negative 2 equals to negative 1x, and then divide by negative 1, divide by negative 1. On the left-hand side, I'm going to get a 2. On the right-hand side, I'm going to get an x. I claim that's my answer, but it is possible to do perfect algebra and get an answer that doesn't check. So that last step of checking is a big deal here. To get my checking, I'm going to go to the original problem before I made the denominators the same. And I'm going to check by plugging in what I think the answer is, which I think it's 2. So I'm going to see if when I plug in 2 for both x's in the original problem, if the left side and the right side simplify to be the same number. The right side's already simplified, I don't need to work with it, but I need to simplify the left side by going fraction 14 over 3 times 2 minus fraction 5 over 2. If I get negative 1/6, then I know my algebra is right and the answer checks. And I did, so I'm good here. So I've checked and I don't need to do any more for that. If you're doing number 1, you're going to get the same denominator of 6x. In number 4, I want to use the same strategy. Make each fraction have the LCD, clear the fractions, solve, and check. But in number 4, not all the pieces are a fraction, so I need to make every piece a fraction. So the 7 over x wasn't an issue, but the 2, I need it to be a fraction by multiplying it or writing it over 1. Each denominator is going to need a single x, so let me give the 2 that single x by multiplying it by x over x. Each denominator now has the single x. Now each denominator has to have a number before the x, and since the 2 denominators that I'm starting with don't have any number between the x, I can easily turn those into a 4 by multiplying both fractions on the left-hand side by 4 over 4. When I do that, the 4 times 7 in the first numerator becomes 28. The denominator of the first fraction is 4x. And then 4 times 2x is 8x. The denominator, 4 times 1 times x, is 4x. And on the right-hand side of the equal sign, you have 1x over 4x. That's making each fraction have the least common denominator. Now I'm going to clear the fractions. I clear the fractions by putting the entire equation in a big parentheses. I put the denominator, the common denominator, to the left of the parentheses and cancel, 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 cancel. This is going to leave me with 28 minus 8x equals 1x. If there was a square, I'd set it equal to 0 and factor. Since there's not a square, I'm going to get the letters on one side and divide. So I'm going to get the letter on the right-hand side just because it's going to be easier. I think I'm going to get a fraction answer. If I didn't have this calculator, checking would be just an awful, awful experience. So since there wasn't a square, I got the letters on one side, and I'm going to divide. I'm going to just scan my work real quickly to make sure I don't think I've made a mistake before I jump into checking, because checking a fraction is kind of challenging anyways. So technically, I should say this is a possible answer. I shouldn't commit to calling it an answer just yet because it may not check. So let me see. 728, boom, 4x, 8. It looks right. So how do I check? I need to take the original problem, which is 7 over x minus 2 and equals to 1/4. Change the x to 28 over 9. So this is going to be 7 over 28 over 9 minus 2 equals 1/4. Quite honestly, that doesn't look like it equals 1/4 at all to me. I don't see a 1/4 there, but I don't need to see it. My calculator needs to see it for me. I don't want to do that by hand. So fraction, put the 7 in the numerator. There's the 7 in the numerator. Arrow down to the denominator. Hit the fraction key again so I can get a fraction in the denominator of 28 over 9. And then I might have to use this mousy right arrow a couple times to get the cursor completely out of the fraction. So arrow once, arrow twice. Now it's out. Now the minus 2 part of this, I hit equals. Oh, thank gosh. Gives me 1/4 equals to 1/4. So I know my answer is correct. Realistically, there's a trick to know whether an answer is going to check or not. If you don't make an algebra error, if when you try to check the answer, you get a 0 in a denominator, or the answer that you think is correct makes the denominator 0, that's the kind of answer that doesn't check. So real quickly, we'll move on to the next page. And again, I'm going to get common denominators. And in problem 6, as well as your problem 5, I have a piece that's not a fraction. I'm going to make it a fraction. I don't know if it matters, but that 8 over x squared, I'm going to temporarily write it 8 over double x, or x times x. It's going to make it easier for me to get the common denominators. The first fraction, I can make it have anything because it doesn't have anything to start but a 1. I need to get double x's in this middle denominator because I need to have the same number of x's in every denominator, and since that denominator had 2, all of my denominators need to have 2. This 1, I'm going to get at the double x as well. Now if I look at this denominator, it's a double x, double x, double x. I'm feeling good. Let me just clean this up a little bit. This numerator right here is 1 times 2x's. That's just x squared. The denominator is 1 times 2x's. That's just x squared. That's really 1. The middle fraction I can write as 2x over x squared. And to the right of the equal sign, I get 8 over x squared. So I've got my common denominators. Now I'm going to clear the fractions. Make a big parentheses, write the common denominator to the left of the parentheses, and cancel, 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 cancel. That's going to leave me with an equation that needs to be solved. If there's a square, I set it equal to 0 and solve by factoring. So I need to solve this, and because there's the square, I set to 0 and solve by factoring. If there's not a square, you get the numbers on one side, the letters on the other, and divide. So I'm going to solve. I'm going to minus 8 from both sides. I'm going to get 2 answers. They'll check separately, and I'll have to check them individually. To factor this, I'm going to cite factor because there's not a number in front of the x squareds. The numbers that I put in the parentheses need to multiply to negative 8, add, that's really subtract, to negative 2, and it's going to be 2 and negative 4 because 2 times negative 4 is negative 8. 2 plus negative 4 is really 2 minus 4, which is negative 2. So one parenthesis gets a plus 2, the other parenthesis gets a minus 4. I'm going to sight solve these. I'm not going to do the algebra. Just going to change the sign. The first parenthesis gives me a negative 2 for a potential answer, not guaranteed until I check it. The second parenthesis, if I set it equal to 0, I would add 4 to both sides. And that's the other answer that I want to check. Realistically, if I don't make a math error, the only way an answer is not going to check is if when I plug it in, it makes one or more of the denominators 0, and those solutions can't be included in my answer. First, I'm going to check negative 2. I'm going to go 1 minus 2 over negative 2 and see if that equals 8 over negative 2 squared. That's easy to check by hand, but why do it? So I'm going to go 1 minus fraction 2 divided by negative 2 to simplify the left side. The left side simplifies to be 2. On the right side, I'm going to do 8 divided by parentheses, negative 2 in the parentheses squared. And the right side becomes 2. So I know that negative 2 is an answer because when I plug it in, I get a nice true statement. I'll do the same thing for 4. I'll use this equation and plug 4 in. Go 1 minus 2 over 4. See if that equals 8 over 4 squared. Since I'm not getting a 0 in any denominator, that should check unless I made a math error. So let me go 1 minus fraction 2 over 4 for the left side. That gives me 1/2. On the right hand side, I'm going to go fraction 8 over parentheses 4 squared. Didn't really need the parentheses, but it's safe. So I'm good. Both of those check, so the answer that I wrote down is fine. Pretty soon here, I'm going to start running into the answers that don't check. For problem 8, let me deal with the single y first. this middle denominator has a single y without any adding or subtracting, I need to give it to both of the denominators that don't have the y. Let me write this bigger because this is kind of cramped. So the original problem is just this. I'm going to give the first fraction a single y in the denominator by multiplying it top and bottom, and to the right of the equal sign I'm going to give a single y. Now all my denominators have single y's multiplied by a number, in this case 1. I need to make all the numbers before the y's the same, and I could turn a 2 and a 3 into a 6, so I'm going to get a 6 in front of each of my y's. First fraction I'm going to multiply by 3 over 3, and that's going to make the first fraction have a 3 and a y squared over 6y. The middle fraction has the y, but it's missing the 6. The middle fraction, I'm going to give it top and bottom a 6, and that's going to make this plus 12 over 6y. To the right of the equal sign, I have the y. I need to change the 3 into a 6, and I'm going to multiply it by 2 over 2. And this is going to give me equals 20y over 6y. Just like problem 6, I have a square. After I get the fractions cleared, I'm going to need to set it equal to 0 and solve by factoring. So I've done finding the common denominator part of this. Now I'm clearing the fractions. When I clear the fractions, I get 3y squared plus 12 equals to 20y. Because there's a square, I'm going to set equal to 0 and solve by factoring. I'm going to minus 20y from both sides and get the left-hand side written in a good order. The good order for the left-hand side is going to be 3y squared minus 20y plus 12 equals 0. I'm going to group factor that in a second. I'm going to multiply the 3 and the 12 to group factor. The 3 times 12 multiplies to be 36. I'm going to need double negative numbers that multiply to 36 and physically add to negative 20. And those are going to be negative 18 and negative 2, because negative 18 times negative 2 is positive 36, and negative 18 plus negative 2 is negative 20. So when I go to factor this, the minus 20y, I'm going to make it minus 18y and then minus 2y. So this is going to give me 3y squared minus 18y minus 2y plus 12 equals to 0. Insert my parentheses. First parentheses, I'm going to factor out a common factor of 3y and be left with a y minus 6. I stuff that negative in the second parenthesis so I can factor out a negative with the common factor, and the common factor is 2, so I'll factor out a negative 2. I have to be left with a duplicate parentheses, so I'm going to not even think about it and just write that parentheses down again. So in terms of factoring, I get y minus 6 times 3y minus 2 equal to 0. The y minus 6, I know that that gives me a solution of 6. I don't really need to do the algebra for it. But that 3y minus 2, maybe I need to push through some algebra. So the y minus 6, if I set it equal to 0, I don't really need to do the algebra. But the algebra would give me 6 for an answer. The 3y minus 2, I would have to add 2 and divide by 3 to get my answer. When I add 2, this would give me 3y equals to 2, and then divide by 3, and get y equal to 2/3. I need to check both of those into the very original problem. So the original problem was y over 2 plus 2 over y equals 10/3. Let me start off and check the 6. I want to see if 6 over 2 plus 2 over 6 equals 10/3. And again, if I didn't have such a nice calculator, this would be awful to do. So well worth investing in this, sub $20 calculator. So 6 over 2 plus 2 over 6. Perfectly it checks. I get 10/3 equals to 10/3. So I know that the first answer of 6 is correct. Let me now check 2/3. To check 2/3, this is hard. I have to do 2/3 over 2 plus 2 over 2/3, and that has to equal 10/3. That's hard even to enter on my calculator. Let me change these to divisions. The first one I can write as 2/3 divided by 2 to make that not a 3-leveled fraction, which is harder to enter. The second one, I'm going to go 2 divided by 2/3 to make so that's not a 2-leveled fraction. It's just easier to enter, and make sure that equals 10/3. So rather than fussing with the 3-leveled fractions, I change the fractions to divide. The first one is 2/3 divided by 2. After the plus sign, I get 2 divided by 2/3. Whoa. First one is 2/3 divided by 2, and then plus 2 divided by fraction 2/3. This is simplifying the left side. The right side is already 10/3. I better get 10/3, and I do, so I know my answers are right. Realistically, I didn't really have to do this much checking. We'll find out real quickly, maybe on the next problem, that the only time an answer doesn't check is either A, if I make a math error, which happens probably frequently, or B, if I don't make a math error and I try to check and I get undefined because one of the fractions denominator becomes 0. Alrighty. One of these times I'm going to get a bad solution, and I think it's number 10. In number 10, again, I'm going to get an LCD for all the fractions. The two right fractions have single x's. I'm going to get the first fraction to have that single x by multiplying by x over x. That's going to make that denominator have a 3x. Second fraction, the numerator doesn't have a parentheses, but I'm going to need to stick one in because I'm going to need to multiply and that parentheses will make me multiply correctly. So I'm at the point now where each denominator has a single x. I also need to get a 3 in front of each fraction, which I'm going to do top and bottom here, top and bottom here. So what I have right now is x squared over 3x. I'm not going to multiply out that right numerator. The minus sign is dangerous, so I'm going to leave it until I clear the fractions. But the other numerators, it's not so dangerous to multiply out. So I have my LCD. Now I'm going to clear my fractions, make a big fraction with a denominator, or with a 3x, the common denominator out front, and then cancel, cancel, cancel. This is going to give me x squared minus 3 times x plus 1 equals 15. I need to solve, and because there's going to be a square, I need to set to 0, factor, and solve for the next step, and then the last step I'm going to check. So the parentheses that I left in, I clear by going minus 3 times x, which is minus 3x, minus 3 times 1, which is minus 3. I don't have my 0 yet, so let me minus 15 from both sides to get my 0. On the left-hand side, the double negative, the minus 3 and the minus 15, give me a minus 18. Made the right side 0. I'm going to cite factor because there's not a number in front of the squared term. The numbers need to multiply to negative 18 and add, that's really subtract, to negative 3. And those numbers are going to be 3 and negative 6 because 3 times negative 6 is negative 18. 3 plus negative 6 is the same as 3 minus 6, which is negative 3. So one of my parentheses is going to have a positive 3. The other is going to have a minus 6. I still have the equal 0. Those I can sight solve. The first gives me a -3 for an answer. The second gives me a +6 for an answer. I think this is going to be correct. Both of these are going to check because I don't think I made a math error, and neither one of these numbers, if I plug them in, give me a 0 in the denominator. So the checking part, I should see if the fraction x over 3 minus x plus 1 over x equals 5 over x works for both answers. First, I'm going to check -3 and see if -3 over 3 minus -3 plus 1 over -3 equals 5 over -3. The right-hand side is just -5/3. That negative I can bring up to the numerator or move out front. There's nothing really to do there for my calculator. But the left-hand side, I have -3 over 3 minus fraction -3 plus 1 over -3 over -3. And that left-hand side comes out to -5/3, which is matching the right side, so I know that that answer is okay. Let me squeeze in checking the 6. To check the 6, I'm going to see if 6 over 3 minus 6 plus 1 over 6 equals to 5 over 6. Just taking each of the x's, all 4 x's in the original problem, and changing them to 6. Right-hand side's already done for me. I won't worry about it. The left-hand side, I'm going to go 6 over 3 minus fraction 6 plus 1 over 6. Hopefully I get 5/6, and I do, so I know that's also correct. So my answers are okay. If any of the denominators would have became 0, when I tried to check, I would just stop and say that's not an acceptable solution. When you get undefined in the checking process, that we consider not checking, and we don't include that in the solution. We call it an extraneous solution when that happens. We say it doesn't check in the solution, it's extraneous. 12's got to be where that extraneous solution comes up. In number 12, that far right denominator has a single x, and I'm going to give the other fractions that single x. So the first fraction, I'm going to give it the single x that the far right fraction has. The middle fraction, I'm going to give it the x that the far right denominator has. So now all the fractions have single x's in the denominator. I need to also make sure all the denominators have a 2 out in front of the x. So on the right-hand side of the equal sign, I'm going to multiply by a couple of 2's. And this is going to give me x squared over 2x minus x times x plus 2, which I'm going to hold off on multiplying out, over 2x equals -4 over 2x. Got my LCDs. Now I'm going to clear the parentheses by multiplying through by the common denominator and hack it out, hack it out, hack it out. This is going to give me x squared minus x times x plus 2 equals -4. -4. Now I'm going to clear the parentheses. I'm going to leave the x squared on the left-hand side. I'm going to go minus x times x is minus x squared. Minus x times 2 is minus 2x. This is surprising me. And on the right-hand side, I just have a -4. It looks like I have a square and that I need to solve by setting it equal to 0. I feel like I have a mistake, so I'm scanning my work as I'm talking. I don't see a mistake, so I'm going to keep going. On the left-hand side, it looks like I'm going to have to set this equal to 0 and solve by factoring, but this is one of those rare instances that the problem has x squareds, but the x squareds cancel. And it's not a solve by factor because there's no x squareds left. I guess this is actually going to work if I haven't made a math error. I'm worried right now that I've got something going on, but we'll find out. If I make a mistake, I'll try to hunt it down. If not, if I can't hunt it down and I have a mistake, I'll just do the problem over. I'm going to check. I'm going to plug 2 in for all these x's. I'm going to see if 2 over 2 minus 2 plus 2 over 2 equals negative 2 over 2. Taking all the x's and changing them to 2. The right-hand side is easy. Negative 2 over positive 2 is negative 1. I don't really need my calculator for that. But the left-hand side's calculator worthy. It's 2 over 2 minus fraction 2 plus 2 over 2. Hopefully I get negative 1. And I do. So this is still not an instance where I've generated a solution that doesn't check. Let me get one more problem in, and then we'll make it into a part 2. For 13 and 14, we have a denominator that's factorable. I'm going to factor the denominator in 14, like you should in 13. To start off in 14, the denominator of 4x plus 16, I'm going to pull out the common factor of 4, and be left with an x plus 4. So when I look at my fractions, I like getting the letters dealt with first. That fraction has an x plus 4 in the denominator. I'm going to sneak a parentheses in that denominator just because I'm going to need it in a little bit. Two of the denominators have x plus 4s, one of them doesn't. Let me make both denominators, all the denominators have the x plus 4 by giving it to the far right fraction. Now all my fractions have x plus 4s in the denominator. I need to get the same number in front of the x plus 4s, and I think I can get this 4 in front of that by multiplying by 2, in front of this by multiplying by 4. So I'm going to get a 4 in front of my x plus 4s by multiplying by 4 over 4 for the first fraction, by 2 over 2 for the last fraction. This is going to give me 12 over 4 times x plus 4 equals 2 over 4 times x plus 4 plus 10 times x plus 4 over 4 times x plus 4. So now all the denominators are the same. Make my big parentheses and clear the fraction by multiplying by 4 times x plus 4. Clear the fractions. This is going to give me 12 equals 2 plus 10 times x plus 4. Fractions are gone. I don't see a square, so I'm going to get the numbers on one side, the letters on the other, and solve by dividing. I'm going to work on that right-hand side. The 10 times x plus 4, I'm going to make it 10x plus 40 by multiplying the 10 times x and the 10 times 4. I'm going to combine the 40 and 2 on the left-hand side and get 12 equals 10x plus 42. And then minus 42 minus 42. Make sure I don't mess up here. 12 minus 42 is negative 30. So this gives me negative 30 on the left side. I still have the 10x on the right side. I'm going to divide by 10, divide by 10. This is going to give me negative 3 equals x. Let me check it. This is still going to work. I'll be darned. So I'm going to go here and check negative 3. I'm going to go 3 over negative 3 plus 4. Make sure that equals 2 over 4 times negative 3 plus 16 plus 5 halves. None of the denominators looks like it's going to be a 0. This should check unless I made a math error. I just can't remember where those funky answers started coming up. Left-hand side, when I check it, I get 3. Right-hand side, when I check it, I get 2 over 4 times negative 3 plus 16 plus 5 halves. Right-hand side, when I check it, I get 3 again. Can put a big old check mark, and the answer is x equal to negative 3. We're at 35 minutes, so let me pause and make a part 2 to this.